Okay. Okay, everyone, and it's time to begin the next session. And let's welcome Oliver Harry and his presentation, Introduction to Scientific Programming in Python.
Hello, everybody. So I'm Olivier, and I will introduce you Python for scientific programming today. I would like to make a quick poll. Who is using Python for data analysis or scientific task every day? Yeah, so not a lot of people, so I hope you will learn a lot of things in this talk. Okay, so why this talk? In fact, this talk is born on Twitter. It's not my initial proposal for this PyCon. I would like to talk about error management, but I'm not here for that. But this guy on Twitter show you, I don't know if this guy is in this room right now. Yeah, it's you. Say something in Japanese, because I can't read Japanese. About Scipy and Numpy, this is only two words I can understand in this tweet. And a friend of mine, Paul, which is French too, say, hey, you have made a proposal for the PyCon GP, Japan, and apparently they're looking for people that can talk about NumPy and SciPy subject. And to be frank, I'm not a scientist, I'm a developer. It's not the same kind of job. So it was difficult for me to talk about a scientific thing like the previous talk. So I just can make a brief introduction to NumPy and SciPy as a developer. And after that, if you want to use it for your scientific problems, so you can dig into the documentation and use it. Okay. So when I see the schedule of the conference, I was really surprised, because there is usually when you go to the PyCon, the room is always packed of Django developers or Flask developers, and there are very few talk about numerical analysis with Python. And here the schedule is almost full of subject about Python for data analysis. So I would like to say that I'm sorry if you learn nothing, because all have been said in the previous sessions. So what do you have to expect from this talk? I will make a brief tour of the libraries that can be used to solve mathematical problem in Python. And I must say that the correct syntax is must, tools that must be used by everyday scientific programmer, because they are so essential for the problem solving with Python that you can't afford to use them. And at the end of this talk, I will give you some guidelines of how to industrialize your work. I will not talk about Puppet or SaltStack or something like that. I just will have a few advices about how to industrialize scientific work. So a few words about me. So I'm a software engineer at TinyCluz. TinyCluz is a French startup in Paris, and we're building a SaaS CRM predictive platform. So basically, we are trying to guess what you want to buy. So Silver Egg, which is the company of the previous speaker, is maybe the same kind of company, but in Japan. So it's my first conference in Japan. I'm really happy to be here. I have 10 years of experience, and I code in Python since 6 years. So I was really concerned by the keynote this morning, because I was totally agree. You can find more about me on my About Me page, and these slides can be found right now on my Speaker Deck account. So let's start with the first tool, which is IPython. Who uses IPython here? Not everybody. So IPython is a must use. I'm serious. Every Pythonista should use IPython. So if you don't use it, install it now, okay? What IPython provides, it provides basically three kinds of things. The first one is a powerful shell, which is much more better than the standard Python REPL. This shell comes into two flavors. One is run directly in your terminal, and the other one, which is a Qt console. The main difference is the Qt console supports plot inlining. We will see this later. It supports also tools for parallel computing, but I don't cover this subject today. But the documentation is really comprehensive, and it's not in the scope of this talk. And the last thing is Notebook, which is a browser-based interpreter that support text, mathematical expression, inline plot, etc., etc. Oh, sorry. In fact, Notebooks supports literate programming. So literate programming is a concept introduced by Donald Knuth, maybe in the late 70s or 80s. And the principle is really simple. He say, well, when you write code, okay, you have some comment in your code, but what do I want to do is to have a comment and inside some code. And this is what can be done with a Python notebook very simply. So you're working on your session. You see in the first talk of this afternoon a notebook. And after that, you can save it and share your session. And now, IPython, so I'm sorry, because I say often IPython, because this is the French way to say IPython. So when you have IPython, it stands for IPython, okay? This notebook are now the de facto standard to share Python session. You can go to nbviewer.ipython.org. There is a ton of sessions that can be seen. And it's really easy. You just register your session on Gist or your GitHub account or whatever else, and you just have to copy it and register it on nbviewer. The project is really well maintained, very stable. Now they secure their funding because Microsoft gave $100,000 last year for the IPython community. And, well, it's a must use, frankly. You should use it. The second tool, and now you know, all use with really know Numpy because we talk about Numpy since the beginning of the afternoon. The second tool is Numpy. Numpy provides a powerful n-dimensions array object. And why it is powerful? It's because methods on these arrays are backed by a very old and very well optimized library, such as Atlas, BLAS, and it has also the support for the math kernel library provided by Intel. The other thing that is cool with Numpy is Numpy is tolerant to Python's list, and sometimes it helps a lot. I made these things, which is a bit ridiculous. I've just wrote a method that implements matrix multiplication, and I've compared this method with Numpy. So if you're familiar with mathematics, you will see that my multiplication method has no optimization at all. It's just pure matrix multiplication. And you will see that even with a very small matrix, the dot method of NumPy is really, really, really speeder. And when you comes to big matrices, and trust me, when you're dealing with big data, 1,000 by 1,000 matrices is small. In fact, you don't want to use my method at all. So what are the lessons here? The first one is you don't want to implement your matrix multiplication method. You never want to do this. Why? Because in fact, NumPy inherits from its dependencies from year of optimization of every kind and of year of work by researcher So you don't want to doubt on their capacity. In fact, Numpy provides for me the best of two worlds. The first world is a world of speed, when you want to implement your method in C, Fortran, because it's fast. And it inherits from another world, which is the world of expressivity, because it's in Python. So Numpy gives you the power of C code in a very expressive way. So this is a must use. The last point I want to mention is sometimes don't believe benchmark about Python. I'm a bit how can I say? Well, this is Julia benchmark. This is on the website of Julia. I have nothing against Julia. I think it's a pretty good project, in fact. But the benchmark method that they use to measure the Python performance compared to Julia are all written in pure Python. And if you re-implement some of these methods with Numpy, I'm sure that Python, it's like the same thing as IPython because we say Python in France. Python will be somewhere between Fortran and Go or JavaScript, but not that far away. I can believe that the quicksort algorithm is 10 times slower than in Python than in Julia. If you use the Numpy quicksort, I'm almost certain that it's the same, almost the same than Julia. Next project is Scipy. The previous talk talked extensively about Scipy and the sparse data structure. So what provides Scipy? Scipy, in fact, is developed along on the same website than Numpy, so it's kind of the same project. And it provides numerous numerical routines that run efficiently on top of Numpy for lots of kind of different problems, like optimization, signal processing, linear algebra, image processing too, etc. It provides, like we saw a few minutes ago, convenient data structure like compressed sparse matrix and spatial data structure. I would like to outline one point that I have not been said in a previous talk, and it's a request also. In fact, compressed sparse matrix are sometimes not computationally efficient with Scipy. When you're dealing with very large matrices, in fact, you sometimes want to convert your matrices to dense matrices to benefit from speed improvement given by BLAS. So if one want to dig into the code of sparse matrices to implement something with multi-threading and multiprocessing, it would be great. Thank you. If you have already used some Scikit, like scikit-learn, in fact, you already have used Scipy extensively. I will come back to some Scikit. As a developer, I found that Scipy is really a difficult library to understand because it is focused for mathematician. And if you're a mathematician, I think you will find lots of treasure in Scipy library. But as a developer, trust your mathematician. The next tool is Matplotlib. In fact, you can render graph like this on Matplotlib now. This is a plugin, so you can have your graph can have the look and feel of XKCD. It's really fun. So Matplotlib is the ultimate plotting library for Python, and I think that other languages are a bit jealous of Matplotlib, frankly. For the first version of Matplotlib, the developers try to mimic the MATLAB API to facilitate the transition from MATLAB user to Python. And well, it remains nowadays. Once again, it's the same for Numpy and Scipy. MATLAB is a very mature, a very stable project. You can expect 1 or 2 releases per year, but your code will work one or is on the other. And I'm short in time today. I just have 45 minutes, but I recommend you to watch, if you want to be proficient with Numpy and Matplotlib, Introduction to Numpy and Matplotlib on YouTube. It's a 4 hours long video, so much more longer than my talk, but it's really comprehensive, and you will learn a lot, a lot. So these are some output of Matplotlib. So this one can be found directly on the Matplotlib website. So there is a code to generate this kind of graph. Scikit-learn. Scikit-learn is one of the numerous library scikits that have developed in the last years. So we have also Scikit stat model, Scikit image, and some other one. It provides a ready-to-use environment to play with top-notch machine learning algorithm. And it has a very, very clean API. There is no surprises. It's really easy to use. The project is now very active. I have an awesome community. I must say for this last sentence that there's a bias because most of the developers live in France and are some friend of me, so yeah. The last project I want to talk today is Pandas. We saw Pandas in action in the first half of the afternoon. And it's a fairly new project because it open sourced in 2009, but the development is really active since 2 years. What it provides a data manipulation library on top of Numpy. And in fact, it consists of one big structure, which is the data frame structure that can be used to indexing, accessing, merging, grouping data. There's some criticism about Pandas. I don't want to fall into that game, but the only point that is real is that yet it doesn't play well with Scikit. There is some attempt, especially for Scikit-learn, which is named Scalar Pandas. But well, it works. You can use Pandas and Scikit-learn. I don't say that you can't use it. But I would like to make the same talk in 2 years, because maybe in 2 years I will say, well, if you want to make scientific programming in Python, just pip install IPython, pip install Pandas, and that's all. But right now, you need all this tool I show you today to make some kind of task and some kind of another task. So maybe in a near future, Scikit will be really well integrated into Pandas, and maybe you could totally merge with Pandas. In fact, Pandas has already a very good integration of Matplotlib. Okay, so this is the time for a small demo. So let me. So this is one again IPython notebook. Does anybody know how it works? Is everybody? I never play with notebook on IPython. Everybody know how it works? Fine. Okay. So this is a pure literal programming. So here you have a heading. You can insert a lot of different things alongside your code, but you know already that. And you can, after that, insert some kind of code. So here I just demonstrate some capability of each libraries. It's really hard to go in deep details. But I just play with the normal distribution of Numpy. So Numpy has a random module that can be used to generate some data. So I use the normal method of this module to generate a normal distribution. So with mean at 0 and a standard deviation of 0.1. And I draw 10,000 sample. I just show here the efficiency of the sort algorithm of Numpy against the sort algorithm of Python. So this is much more faster, but I think I made a mistake because I think that sort algorithm of Numpy is in place, right? I don't know. Well, maybe it's a little worse for Numpy, but you have always a great improvement. So after that, we can draw a very fancy histogram. Whoa. So here it's simple. I've taken my series. When you launch a notebook with the PyLab mode, in fact, matplotlib.pyplot methods are all imported and you can use it directly. So plot, ist method are available on the top of are directly usable in your notebook. So this is program, and now if you want to draw the probability density function, which is expressed like this, and this is a LaTeX formula that can be introduced between $$ on your notebook. So I define this method, and now I draw it, and whoa, wonderful probability density function. Yeah. So you see, with a very few line, I can benefit from graphics, like in very expensive software like MATLAB. So here I'm playing with Lena and Scipy a bit. So I say hello to Lena. So as I said in my slides, Scipy comes with a lot of method to solve standard problem, and you can just play with the Sobel filter on images. So the Sobel filter is used to emphasize agent transition in images. So you just have to show Lena on which I apply the Sobel filter, and I will display the result on a color map, which is black and white, and here is the result. So it's really, if you just want to use a Sobel filtering for any purpose, it's really simple. Immediate. The last thing I want to show you is playing with a standard dataset, which is Iris. So this is not a fancy dataset, I'm sorry. But it's a very classical problem in machine learning. In fact, Iris is a flower, and there is 3 kinds of this flower. And it's really easy to differentiate this flower just by looking the length and the width of petal and sepal of this flower. So so all these examples are on the website of Scikit-learn, so you can find them very easily. So the first thing is I will display this dataset in 3 dimensions. So I say that we have 4 features: the petal length, the petal width, the sepal length, the sepal width. Unfortunately, we can't see in 4 dimensions. So I have to reduce the dimension to 3 dimensions, and I will use a standard algorithm which is named PCA for principal component analysis to reduce the number of dimensions of this feature to 3. And so I obtain this graphic. And you see here, you have a kind of spaces which is really different from the red and orange species. But even in red and orange, you can see a small difference. Okay? If I'm looking just on 2 dimensions for sepal width and sepal length, I saw that the blue spaces here is really different just by looking the sepal width and sepal length from the other one. Okay? So I have a good indication here that I can develop an algorithm that will be used to differentiate Iris spaces. So let's have a look to the Iris dataset that is contained in Scikit-learn. As I said, this is the 4 features for each sample. The dataset contains 160 samples, I think. And here is the target, so the kind of flower the kind of iris. There is a iris 1, there is 0, and there is 2, which are named Setosa, Versicolor, and Virginica. So I will take this dataset. I will concatenate the target with the data. I will split the dataset with took a test size of 10 sample, and I will learn. My algorithm will be fitted on the rest of the dataset. And this is what I say by it is really simple to use a model with scikit-learn. This is this 3 line. You just declare a logistic regression model. So you have a lot of parameters to tune, but at the beginning you don't care, you just want to use scikit-learn. So it's always time after to look at parameter and how they can influence your algorithm. So you fit your model on your trained dataset. So I will take the feature column, and this is the way I take the target column. So I say train your model by looking at the feature and what is the result of this feature. And then predict the spaces based on my test dataset. And this is the result of the prediction. So I have, for all the sample in my test dataset, I have the 2, 2, 2, 2, 2, 2, 2, 2, 0, 1, 0, 0. And the test dataset contains 2, 2, 2, 2, 2, 2, 2, 0, 2, 0, 0. So this is a test dataset of 10 sample, and in 3 lines I have an algorithm with an accuracy of 90%. I have do nothing that use what is available for me. Okay. So this is another plot that will draw the decision boundary in 2 dimensions for all the algorithm, but I'm a bit short in time. So once again, all is contained in the scikit-learn documentation. I have something also on Pandas. This is based on an article on the web. We saw extensively Pandas today, so maybe I will skip because I'm a bit short of time. But basically, this is a tool to you can make some group by operation, lots of operations that are very common when you're using SQL, and it comes in a very easy way. It's really easy to use. Okay, so let's get back on here. So the last thing I want to talk about in this talk is, okay, you have your prototype that works on your local computer, and now you are ready to go to big data. Okay. In fact, Numpy, Scipy, scikit-learn, as I said, rely on many low-level library. Most of the time, they come on your system unoptimized. For instance, this is not true on macOS because the build of BLAS on macOS 6 is optimized. So if you are using, for instance, Ubuntu, BLAS by default will be only monocore. And trust me, when you have a big instance with a 64 processor, you want to use them. So you may want to recompile these libraries. But at this step, stop. Really, you really have to stop. Why? Because recompile is a very long way. It is very long to compile Atlas even on a modern computer. We did that in my company, and we decided to stop because it was really too difficult when you're using continuous delivery, continuous management, etc., to tackle those challenges imposed by the compilation of this kind of libraries. So instead, there is a limited set of Python distribution like Anaconda, Canopy. So you should use one of them because they come from free, and they have a package for optimization which are really cheap when you are a company. So you choose use one of these distributions. Sadly, the bad part is that each of the distribution comes with their own package manager, and sometimes it doesn't play really well with pip and easy install. So expect some issues with the package manager of each of these distribution. So this is almost the end of this talk, but I talked just about 5 or 6 libraries, but there are many more. You can have other library for performance like Numpy, which is a JIT compiler for Numpy. You have Cython. You have Scipy for or NLTK for domain-specific. These are domain-specific library. You have bindings on R. And you have also a library for storage like PyTables and so on. There is a very rich ecosystem, and I'm sure you will find your need in the cheat shop. Last, a few words about open source. All this library comes from free. Free as in freedom, but free also as in freebie. So please support open source developer, and it's really easy to support them. You can just fill bugs because everybody is happy to see that a project is used. You can fix bugs. You can support them financially. There's a lot of initiative to support developer like Git tip. And you can also help them to host them their sprint if your office is big enough. As a final slide, this is the sprint of the Scikit Learn team hosted in TinyClose in this month of July. Thank you. If you have any question. These are some recommended reading, by the way. I think there is a question here.
Yeah, actually, it was just to ask if, like, are these slides available already online somewhere?
Yeah, on my speaker deck. Here.
Okay, thanks.
Yeah, just wanted, there is already an implementation of multiplication of sparse matrix using OpenMP and NumPy, so
yeah,
can I use it?
Yeah,
so you find it online?
Yeah, we use it for a couple of weeks in TinyClose, in fact. But we already did the work before, sadly. So we have a very specific way of multiply CSR matrix that we develop in-house. But well, maybe we should contribute to Scipy. This is in our plan, but you know, when you have a very specific and very optimized code with a lot of Cythonization, it works on our target environment. But when you want to open source the thing, it has to work on every kind of environment, and it's more difficult. Yeah, but when we have the time, maybe we will contribute.
Okay, thank you very much, and let's applause for Oliver Harry. And next, we have 40 minutes to have a break time, and in the 40 minutes later, let's begin the next session. And on the right side, we have a coffee for you, and if you like it, just for it.